let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Now look closely at the light bulb, and you'll notice that there is an insulator between the conductor that leads up to the filament and the conductor that leads away from the filament. Remember that the atoms of conductors easily accept and pass on electrons. The atoms of insulators do not. As we discussed in the first section of the lesson, electrons will not easily pass through insulating material that surrounds a wire. If an insulator did not surround a wire carrying a current, it is possible for the electron flow to get directed to another conductor that comes into contact with the circuit. Electricity will follow the path of least resistance. If the electrons take a path short of the complete circuit, it is called a short circuit.